Hello everyone, welcome to Reactify Labs. Today we will do a Leetcode problem, maximum number of tasks you can assign. So let me explain the problem statement to you. I'm assuming if you have come to watch this video, you must have tried attempting the solution. If not, you should try and attempt it. Then you will have an idea of what question says. So I'll not go and read the problem statement line by line. I'll just explain to you what the problem statement says with the examples, and then we will move to the solution. Okay. So basically it says you have some tasks to perform and some workers who can do that task. Okay. So basically, let's say the task is to lift some bricks. And the bricks are of different weights. So let's say here you have 3 bricks to lift and the weights are 3 kgs, 2 kgs and 1 kg. And you have some workers who have some level of strength. And the condition says that only the worker whose strength is greater than or equal to any particular task can do that task. Okay. And one worker can do only one task. And also it's not that two workers can do one task. Like one worker can do one task can be done by one worker only. Okay. And there is a special thing called a pill. So let's say if if one worker is not able to do a particular task, for example, let's say this worker has 0 strength, then it will not able to finish this task 1, right? But if this worker can take this pill, so there is only one pill here, okay? And if this one worker can take one pill of strength 1, its strength will become 1. Instead of 0, it will become 1. And then this 1 will be able to finish this one task. But still it will not be able to finish these tasks 2 and 3, right? Okay. Now let's see another case. So in this case, if you see, all workers have 0 strength, but these tasks have like 4 and 5, okay? So these bricks have weights 4 and 5, just assume that. But there is only one pill. So any one worker can take one pill. So let's say this worker took it. His strength became 5. So this worker with strength 5 can finish either this task or this task. Okay, because one worker can do only one task. So it means for this, the answer will be 1, right? Means one task can be finished. So you have to return how many maximum number of tasks can be finished. That's what the problem statement says. And in the first case, if you see, this 3 can do this task, this 3 can do this task, and this 0 can do this task after taking a pill. Others don't need a pill, right? So for this, if you see, the answer is 3. And in this case, if you see 10, 10, 10, 10, 10 and 10, 15, 30. So let's say this 10 can do this 10. Okay. Now this 10, when this will try to do this, it will not be able to finish either. So this 10 can take one pill. So now the pill count is 2 and this will get one strength. So the strength of this one will be 20. So 20 can finish this task, right? 20 can finish this task. But now all the workers have strength either 0, 10, 10. And even by taking a pill, it will be only 20, right? Even though 2 pills are left, but one worker can take only one pill at max. You cannot take more than one. So that's why the maximum strength that any worker can have is 20, right? This will have 10, this will have 20, this will have 20. So this worker can also not take they cannot finish the task even after taking the pill. So that's why the answer is this 10 can do this 10 and this 10 after taking the pill will become 20 and can do this task. So two tasks. So 2 tasks can be completed. Okay. So now the question is how are we going to solve this? How are we going to find how many maximum number of tasks can be done? Okay. Before that, there is one more thing. It's not given like the size of this tasks array will be greater than or smaller than this workers array. It can be anything. It can be greater than or it can be smaller than that. Okay. So we need to be aware of that as well. So how can we solve this? One thing is that we can check all combinations, like if this 3 can be done by anyone, okay? Like this 3 can be done by this 3. This 2 can be done by this 3. Yes, this one can be done by this 0. Okay. This is a simple case, but let's say there are some other cases where you have to try all possible permutations and combinations. For example, let's say the simplest way that you can think of is 1, 2 and 3. We will sort the tasks. we will sort the workers, right? So we can see, okay, this 3 can do this 3, right? This 3 can do this 2, right? And this 0 will take the pill and can do this one, right? This is fine. But what if it's, let's say it's like this 0 3, then what? You will arrange it like this, or you will arrange it like this, and how would you compare, right? So if you arrange it like this, you will see that, okay, this 3 can do this task, but this 0 won't be able to do 2, because this 0 even after taking the pill will become 1. So now you have to compare 0 against this, and this is easy here because you had only 3 elements. But if you see the constraints of the question, the constraint says this task length and worker length, this can go up to, not combined, this can go up to 10 to the power 5, this can go up to 10 to the power 5, right? So this can be a lot, right? So which will make it very difficult, or a very inefficient solution if we compare like all possible combinations, okay? And these pills will be like, if we give it size m and size n, so this pill can always be, if we make it p will always be less than equal to m, okay? The number of pills will always be less than equal to m. M means number of workers. So in the best case, it would be like, it will be equal to m. So it means every worker can take one pill. Okay, every worker can take one pill to do the task. But that is, it depends on the problem statement, right? It depends on the test cases, what kind of test cases they are providing. So we have to give a solution which will work for all the cases. So what can we do? What is the best way to do it? So if you see, is there something we can do like this? So we have tasks, right? Let's say we have some tasks. Let's take this example, or let's take a better example, a big example. Let's say 1 4 5 2 4 3 4 5. I don't know the answer to this, okay? We will find out. Next is workers. Just to generalize it, let's make the size of the worker different from the tasks. 2 3 10 3 5 9 7 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 9 6 4, okay, like this. So let's sort it first, okay? So if we sort it, it will be 1 2 3 4 4 4 5 and 5, right? So the tasks are like this, and the workers are going to be, we have 2 3 3 2 3 3, we have 4, then we have 5, then we have 6 7 9 9 10, 3 6 10, okay? Now if you see this thing, if this worker, okay, this is how we are going to think about the solution. How are we going to come up with the solution? So if this 10, like the worker with the maximum strength, cannot do this task, okay, right? If this worker cannot do this task, like the easiest task, it won't be able to do the other tasks. Do you agree? I believe so. You agree? Okay, that's fine. If this worker cannot do this task, that's fine. But if this worker can take a pill and still cannot do this task, then there is nothing that anyone can do. We will have a 0 answer, right? Right. So this is just an example here. We know that here it's 10 and 1, but let's say it was something else. Let's say the task would be 100, 200, and the worker would be like 1, 2, 5. So if this worker 5 cannot do 100 even after taking the pill, it means nothing else can be done. No other task can be done by this worker, and no other worker can do any other task, because the strongest one could not do the easiest task, right? So this is what we are going to apply here. So if the strongest worker can do the this task, like the easiest task, it means yes, we can try others also, Okay. So this is the concept that we are going to follow here. So this one is enough, like strongest worker cannot do the easiest task. This one is enough for us to know that, okay, no one else can do it. So we will just forget about it. Okay. We'll just return that, okay, it cannot be done. Okay. We will use this logic. Oh, actually, let's keep it. So this is a question of binary search. How do you know binary search, or how did I know it's a binary search? So if you see, what did I say? Worker can do the task or not. So if this worker can do this task, actually, if this worker can do this task, then we will check if this worker can do this task. We will check if this worker can do this task. We will check if this worker can do this task, right? We will keep checking until this worker cannot do a task. So instead of checking it from this way, if we start checking from the end, like, okay, if this worker can do this task, can 10 do 5? Yes, 10 can do 5. Then we will now move, okay, can 9 do the next available task? Can 9 do the next available task? We will start doing that, right? So this is what we are going to follow. And for that, again, do we need to check all? Let's say if this 10, if this worker cannot do this task, it means we are not going to check the tasks which are to the right of it, right? So we only need to check the ones right to the left of it. So that's why we need a binary search. So we will keep a point where we have to check. Like, let's say we'll start with this point. Okay, this 10. We will start with the middle. Okay, can you do this? Yes. If it says that yes, it can do this, then we will start, and others also from the mid towards the end. If those can do, then we will say, okay, let's shift the middle. Now we will shift the middle here. Now can 10 do this? Yes. Again, we'll shift the middle here. So this is how we are going to approach this question. This is how we are going to solve it. So before I start, let me tell you a few things which we are going to use here. So first is binary search. If you know, binary search needs a sorted array, right? So first we will use a sort function. Okay. Then we will apply some basic binary search. Binary search as in just checking the high, low and mid, like using the high, using the low, calculating the mid, and using the while loop, while low less than equal to mid. That's what we are going to use. Next, we are going to use a multiset. Why a multiset? Two reasons. First one is it stores the elements in sorted order. Okay. It stores the numbers in sorted order. And it can contain duplicates, unlike a regular set. So these are the reasons why we need multiset. Okay. And another function that we are going to use is lower bound. So lower bound is basically something, let's say for this set, okay, for this set, the lower bound gives you like the number which is greater than equal to a number. Okay. So if I have to talk about lower bound and upper bound, then for 5, let's say for 5, lower bound of 5 will become 5, but lower bound of 6 will be, lower bound of 5 will be, what am I saying? Lower bound of 5 is 5, upper bound of 5 is 6. Okay. Now let's say a number which is not present. So number like 8. So for 8, lower bound is also 8 and upper bound is also 8. For 8, lower bound is also 9, upper bound is also 9. I don't know why I said it. Okay. So what did I say? For lower bound, greater than equal to the number. For upper bound, greater than number. Okay. I'm sorry again for messing this up a little. Again, if we have to say, for lower bound of 5 will be 5, upper bound of 5 will be 6, because 6 is the number which is greater than 5 and 5 is the number which is greater than equal to 5. Okay. For 8, it will be 9. This will also be 9. Why? Because if we say greater than equal to 8, so there is nothing equal to 8, right? Then first number which is greater than or equal to 8 is 9, because it is greater than 8. And lower bound, first number which is greater than 8 is 9. If we take any other example, let's say 11. So there is no number which is greater than equal to 11, right? So it will give nothing. Okay. Actually for the set, it will be end of set, nothing. So for this also, it will be nothing. Okay. One more thing, for 10, the lower bound of 10 will be 10, but the upper bound of 10 will be Again, nothing, because it's not available, right? So it's just the end. You can say it's nothing. So these are the four things that we are going to need. What? These: sorting, binary search, multiset, and lower bound. Okay. So what we are going to do now is we are going to see this. So first we will sort the tasks and workers. Sort the task and worker. Okay. Now we will apply a binary search. Okay. So binary search on what? Now we will see first. So the size of task is n, size of worker is m. Okay. So what we will do is we will take a number, let's say k. K is minimum of m and n. Whichever is minimum, only on that we will apply the binary search, because if you see, if we take, let's say, low as 0 and high as something as 10, and so mid will be 5, right? So if the size of, let's say, task is 6 and size of this is 6 and this is 10. Okay, forget this. I'm explaining why we are using minimum. So if we take this, so the mid is 5. In the next step, the mid will change to 7, right? For this, it will be out of bounds. The index will be out of bounds. So that's why we have to take care of this minimum thing. So if we take the minimum, the high will always be 6. So it will not go out of bounds for anybody. Okay. So that's why we calculate the minimum. Let's say k is minimum of m and n. Then we will apply binary search. So for that we will use low, which is 0. We will use high, which is k. Okay. Then we will go into the binary search. So binary search will just do that while loop of low less than high, and we will check if possible, if a certain task is possible. So what we are going to do is, for these tasks, let's say this is the task array, this is the worker array. So we find the middle. Okay. This is the middle. So we will see if all these tasks can be done by all these workers. Okay. So for the middle, if the workers towards the right of the middle can do all the tasks which are towards the left of the middle. If yes, so what happens? If yes, if they can do, then what we will do? We will move it towards the right. So the now mid will change to this point. Okay. Now the mid will change to this point. But now what we need to do is we need to make sure that, let me change the color. Now we will see that, see, the number of tasks increased, right? So obviously the mid is changed, but now the workers we need these many workers for these many tasks. Now this point will shift to left here. Okay. I will explain how in the code. So this point will shift to here. And now we'll see if all these tasks towards the left of mid can now be done by all these tasks towards the right of this point. Okay. Which we calculated from the mid. If yes, then again we will move it. Again we will move the midpoint. And now we will again check if all the tasks which are towards the left of this point can be done by all the workers which are towards the right of this point, because again, due to the change in the mid, this point also changed, right? So this is what happened, and this is what happens. And if we know, let's say, if at this point we found out, yes, that here it cannot be done, not all tasks can be done, then we'll again find the middle. But in the end, we'll get an answer. At one of these midpoints will be our answer. Okay. One of these midpoints will be our answer. Why? Because we will do like this. Let me change the color again. It's the white color. Yeah. So it's like this. So if we have a mid, let's say if we get the mid now, then we will use a function to check if it is possible. Let's say if it is possible. Let's say the function is possible. So possible means if it is possible, for mid number of workers mid number of workers to finish mid number of tasks. Okay, if it is possible to finish mid number of workers to finish mid number of tasks. If it is possible, then like if possible. So if it is possible, then what we will do? Then we know that our answer is mid. Means it's possible. At least the answer is mid. Can it change? Yes. Then we will move the low. Low will be moved to the midpoint. Like after the midpoint. So now the midpoint is moved. So we know that at least mid number of tasks can be done. Now let's see, can we do more than that? So for that we are shifting the midpoint towards the right, right? Because if low is moved, let's say initially the low was here and the high was here. So the midpoint was here. And now we know that yes, mid number of tasks can be done. Then the low will become here, right? So if low is here, high is here, mid will be somewhere here, right? Now again, if low is here, high is here, mid will be somewhere here, right? So that's what we are doing. We are sure that yes, mid number of tasks can be done. Now let's see, can we do more? Okay. And if it is not possible, then like if it is not possible, so if possible, then this, else what? If it is not possible, means mid number of tasks cannot be done. Other case, if mid number of tasks cannot be done, it means that high will be moved to mid minus 1, right? Means if we have low here, if we have high here, mid number of tasks is here. So if mid cannot be done, we know that, okay, mid cannot be done. Can we do anything less than this? Like how much can we go now? So this high will become come here, and again the mid will be here. Now we'll see, can mid number of tasks be done now? These many tasks. If yes, then again we will shift this low to this point and we'll find this mid. Now we'll see, can mid number of tasks be done here? So this is what we'll continue doing, right? We will just try to find, can mid number of tasks be done? If mid number of tasks can be done, then we will move to check if more than mid can be done until, and we will do it, we'll keep doing it until the terminating condition of binary search, which is while low less than equal to high. And as soon as low and high, like this is low, this is high. And so for mid here, low, then low moves to this point, then mid is here, then low moves to this point, then let's say not possible, then high moves to this point, then low moves to this point. When they meet, we will terminate our binary search. Okay. So our most important function here is this one. If possible. What is possible? How do we know if it is possible or not? Let's focus on that now. If it is possible or not, for that we will go back to the example that we had taken. Let me copy it. Let me copy and here I will paste it. So this is our test case. So for possible, what we are going to do is, as I mentioned in the beginning, we will use a multi-set. Okay. And the possible function, if you see, the possible function that we have has what? We have tasks, we have workers, we have pills, we have strength of a pill, and we will have a mid as well, because the mid that is being passed by the binary search. Okay. So this mid will be there. What we are going to do now is, we are going to first keep it aside. It should be good. Okay. Okay. So we are going to check if it is possible or not. How we are going to check it? As I told you, let's see. Let's calculate it here. Here the size of task is 8. Okay. So our low is 0. Our high is minimum of 8 and 10, which is 8, because size of this task is 8, worker is 10. So our mid is 4, right? So let's see, where is 4? 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. This is the midpoint, right? So what we are going to do is, we are going to check if all these tasks towards the left of this point can be done by these many workers. These. Okay. Who are these workers? So in the multi-set that we have used, in the multi-set, we will populate the workers like this. So workers dot end means from the end we will take mid number of workers and from there till the end workers dot end. Okay, so it means here mid is 4, right? So from the end we will take 4 till this point. Okay, from the end we will take 4, from the end we will take 4 and we will see if it is possible. Okay, if it is possible to do this, if it is possible for these 5 workers, from the end 5 we are taking, right? So it will be like this, the size is let's say 10 minus 4, the index will come to be, let's say 6, then 6 7 8 no, sorry, actually the size is 10, workers dot end minus mid will give us 5, then we will have 5 6 7 8 9, right? Again, if you see, although high is 8, but we need all our workers, right? So this is the way to get it. How do we get the last 5 workers if the index is out of bounds, right? The index will be out of bounds for task, but we are going to handle that. I will show in the code. So in the multi-set, we populated the last 5 workers, last 5 as in the strongest 5 workers, because we have already sorted the workers array. Okay, and we have tasks. So in the tasks, what we are going to do is, sorry, why is it not moving? Yeah, it's moving now. So in the tasks, what we are going to do is, we take the initial 5 tasks, then we will take the last 5 workers. Can they do it? Okay, so we will take like this. We will run a for loop. Okay, over what? We will run the for loop on the tasks. So for I will become, I will go from mid. Okay, so mid minus 1 to I greater than equal to 0 and I minus minus. Okay, so mid minus 1 as in, okay, I said mid, but it will come from mid minus 1. So mid minus 1 will be this point. And here it will check again now 4, last 4. If these 4 tasks can be done by these 4 workers or not. So for I will become, I will go from mid minus 1. Okay. So mid minus 1 means this I has taken already this task. Let's say 4 tasks. We will take it. So we will get the last worker also. So now we will get the last worker. How? So the last worker will be like this, it equal to mid, sorry, not mid, multiset. Let's name this multiset as ms. So ms dot end. Okay, this will be it. Next we will see, we will do it minus minus. Why it minus minus? Because this ms dot end will give us the end, like after the end of this. Okay, it minus minus will point us to this 10. So it minus minus will be done. Next we will see if this task, like if this task I can be done by the worker. So star it. So if this it means star it will give us the strength of the worker. If this worker's strength, okay, if this worker's strength is less than the strength of the task, if this worker's strength is less than the strength of the task, is it? So if it is, there are 2 cases. Either it can be done or cannot be done. So it can be done in the case if the pills are still left and the strength of the pills is also something which is enough for the worker to do the work, right? So let's say we do this. If I, like, the strength of the worker is less than the task, then in that case, what we will do is we will check the pills. If pills are left, if there are no pills left, it means we can just return false, right? If there are no pills left, we can return false. Why? What happened now? What happened was this worker with strength 10 could not do the worker, task 4, right? If the worker cannot do the task 4, what we are going to do now is, like if 10th, like the strongest worker cannot do the 4, like that task. So as like this, see this, if the strongest worker could not do this particular task, it means no other worker will be able to do that particular task, right? So that's why we will return false, because the strongest worker could not do it. How will others do it, right? So in that case, what happens? We will just return and we will try to shift the mid again. We will try to rebalance our left low and high and then try to find from the mid again. Okay, so that's what. The worker is not capable to do the task. That's fine. We were fine with that. But the worker is not capable to do the task even with the pill. And we are not fine with this. If the worker is not capable to do the task even with the pill, we will return false. Else means if we are writing something else, something here means that the code flow is coming to this line, right? So we will find again it equal to ms. In the multiset, we will use our lower bound. As I explained in the beginning, what lower bound is, how it's used. So lower bound means tasks I minus strength. What is this? Now we are seeing that, okay, if this did not run, if this did not run means the pills are still left, right? Actually I made a mistake here. This condition does not check if the worker can do with the pill or not. This condition check if the pill is not present at all. Okay, if the pill is not present, the worker cannot do the task. The pill is not present, it's over, right? Now if the pill is present, means if we have come to this line, it means the pill is present, right? So the pill is present, and now we will find if the worker can do the task now. So the way to find it is, we are checking tasks I minus strength. So basically worker strength plus pill strength should be greater than equal to task, right? So it's like worker strength should be greater than equal to task minus pill, right? So this is what we are trying to find. If there is any worker whose strength is greater than equal to T minus P. T minus P means task strength, task minus pill strength. So task minus strength. And we are finding the lower bound. In the lower bound, we are trying to find if there is a worker, if there is any worker whose strength is now more than, like lower bound is, if there is any worker whose strength is greater than or equal to the strength required for this task after the pill. Okay. Instead of adding the worker's, like adding the pill strength to worker, what we are doing is subtracting the pill strength from task. It's the same thing, right? So that's what we are doing. Subtracting the strength of the pill from the task. Now we are seeing, is there any worker now which can do this task, because now the strength of task has reduced. Actually the strength of worker has increased, but it's the same thing. Okay. If the strength of task has reduced, now can any worker do it? If still there is no worker who can do it, let's say if now is it, if it is ms.end, if it is ms.end. Okay, actually you cannot do this. You will check if it is not equal to ms.end. Okay, we will find this, we will do this now, but we will see the else condition. So if it is not equal to ms.end means there is a worker which is found. Else means there is no worker which can be found which can do the task. Then we will again return false. Okay, if there is no worker which can do the task even after the pill, we will return false. But if we found a worker who can do the task, what will we do now? So we will reduce the pill, because the pill is consumed now, right? Now the pill is consumed, it means, okay, the pill is reduced. The worker has taken the pill, worker has done the task, the number of pill is reduced. That's it. And along with this, what happened? Once this change, this if condition happened, means the task was done. Okay, then we will remove that ms.erase it. We will remove the worker from our multiset. Means, okay, that worker has already done its task. And as I told in the beginning, one worker can do only one task. One task can only be done by one worker. So now the worker will be erased and the task will be taken care of by this for loop. Now the for loop will shift towards the left, right? So this was if condition, means if the strength of worker is less than the task, then okay. But what if it was other way around? If the strength of worker was greater than equal to task, still what we will do is we will remove this worker, right? ms.erase it. So this one will always be there. So we do not need an if else statement. We can just close the if and write this line. It means that it will always be there, irrespective of whether the worker finished the task with pill or without pill, it will always be there. Okay. And in the end, when this for loop ends, this for loop ends totally, like this for loop will end like this, basically ms.erase it. So after this erasing happened, worker got erased. This after this if statement, this for loop completes. Okay, and after the for loop is what? After the for loop is the is possible function, right? So we will return true. It means we tried so many attempts of returning false here and here, still it did not return false. So after all the for loop, after this for loop ends, it means it returns true. And if it returns true, let's go back here. If it returns true, what do? We know that at least mid is our answer. So now we will try to find our answer here. So the mid will change, means first low will change, which in turn change the mid. And now again, we will keep doing the same thing again and again until we find our answer. Okay. So this is what we are going to do. I hope this explanation cleared this concept for you. I'll put the code in the description of the video. Please refer that if you still face some problem in writing code. But I'll suggest try writing the code on your own. First try without watching this video, then try after watching this video, after understanding how the solution works, try to write code on your own. If it still does not work for you, then you can watch the code. Okay, you can watch the solution, you can look at the solution. Okay, do that. So I hope this cleared everything. Let me just quickly summarize it again. We will find a mid. We will find a mid. Okay. We will find a mid. Then towards the left of the mid, whatever tasks are there towards the left, we will try to finish those mid number of tasks by the strongest mid number of workers. If those can be done, we will shift the mid. We will again check if these can be done by these. We will again shift the mid. We will check if these the tasks to the left can be done by those number of workers. Okay, those strongest workers. If the basically the gist was, if easiest or lightest, we have to check if lightest mid number of tasks can be done by strongest mid number of workers. Okay, strongest mid number of workers. This is the whole gist of the question or the solution. You have to just keep finding these using the binary search. Okay, so yeah, that's it. That's all there was in this video. I would really appreciate any feedback on this. If you like the solution, please let me know. If you didn't like the solution, please let me know what I should improve. So I'll try to accommodate those from my next videos. Okay. And if still there is something in this video which you did not understand, please let me know. I'll try to clarify it in comments. So that's all there was in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.